Here we go. Just a quick review. Quick review. I want you to add this. Yes, I want you to add this. Just very quickly. Alright, on this one, you have to force it to have the same common denominator. So what you're going to do is, you're going to take this first fraction right here, okay, and I'm going to multiply him. Well, take that one out. And I want to multiply him by 3. So this is going to look like 3 over 3, because that's 1, correct? I'm still going to bring this down, so plus 1 2/3. And I'm going to multiply him by the opposite over here, so that's going to be 4 over 4. Everybody see where I got my 3 and my 4 from? Now I'm going to go back and I'm going to multiply. The whole number stays the same. It doesn't get multiplied. Well, it technically does, but what's 4 times 1? 4. So he really doesn't change. The look that's going to change is right here. So what's 3 times 3? And what's 4 times 3? Plus 1. What is this? Now, my denominators are the same, so I'm able to add. Start with your whole numbers. What's 4 plus 1? 5. Now, what is 9 plus 8? Now, I notice some of you are adding the bottom. Do not add the bottom. The bottom is just telling me how they're putting that into how many pieces they need it. Okay? So I do not add the bottom. It strictly comes over as the same number. Now, this looks like it's an improper fraction, so I can clean it up a little bit. What is 17 over 12 as a mixed number? 1 5/12. So now I no longer have the 17 over 12. I have 1 5/12. Okay? So I'm going to add my two whole numbers. So 5 plus 1 is? And I keep that fraction. Can it reduce? No. So therefore I'm done. Okay? Now Zach, when you said you divided, that's what we did. I just didn't show that work over here. You would have had that. Okay? You would have gotten the same answer. That's how we got it. Okay? We just did it without showing it on the board, okay? Any questions on adding? Okay. Let's talk about subtracting. Subtracting is the same, except we just subtract instead of add. Okay, now, there does come to be a little point a little later that sometimes we have to borrow. Because you know when we subtract, sometimes if we don't have enough, we have to borrow from somebody that's a little bigger than us. Okay? And so we'll get into a couple of those. But it's the same principles. If I have 7/10 minus 3/10, if my denominators are the same, okay, I just subtract my numbers. Alright, so from here, are my denominators the same? Yes. So I know the bottom denominator is going to stay 10. I'm going to look at the two top numbers and subtract them. What is 7 take away 3? 4. So I have 4/10. Am I done? No. What do I need to do? And I can reduce by what? 2. So 4 divided by 2 is, and 10 divided by 2 is, so this is the correct answer. Okay? Everybody do this one on your paper. I'll give you a mixed number on this one. let's make that a 4. 4 and 7/8. Alright, Myra, what'd you get in your answer? 3 1/2. What'd you get before you reduced to the 1/2? 3 4/8, which is correct. Okay, so some of you may have stopped on the 3 4/8, but you do need to reduce by 2, and 3 1/2 would have been my answer. Yes, sir. Do you reduce this number? No. No, that whole number never gets split. Okay, when I'm reducing, I'm only reducing that fraction. Because remember, from here, you're reducing by 2/2. What is 2/2 as a whole number? 1 whole. So it's 3 divided by 1? 3. So it doesn't change when I'm dividing by that 1. Okay, so the only thing that gets reduced is that fraction part. Okay, Avery? Okay, we're going to actually talk about some uncommon ones here in a minute. Okay, I just wanted to start with the common ones first, that way that we're a little easier, okay? Does anybody have a question on subtracting with common denominators? Alright, so now we're moving ahead to uncommon denominators. Let's say we have 3/9 minus 1/4. Now, just as a refresher, how did we do this if we were adding? What did I have to do first? Okay, I would take the 4 and times it by 3/9, and then, okay, I would take the 1/4 and times it by 9 if I was adding, right? You're going to do the same setup. The only thing is, instead of adding, I'm subtracting now. So you're going to do the same thing. So you take 3/9 and times it by 4/4, because that's what this bottom denominator is. Minus 1/4 times it by 9/9. Now I'm going to go through and multiply. What's 3 times 4?
12.
9 times 4?
36.
Minus 1 times 9? And 4 times 9?
36.
Now what is 12 minus 9?
336.
Can that reduce? Yes, by 3. So I'm going to reduce by 3. So my answer is what? 1/12. Very good. Do what now? Sometimes. Okay? The same steps. Okay? Same principle, same ideas, except I'm subtracting instead of adding. Now, sometimes though, Logan, okay, they look easier and they are easier, but sometimes then they get a little harder. And we're going to talk about a couple of those here in a minute, okay? Anybody have a question on that? One more like this one? Yeah? This one's for you guys to do on your paper right now. Everybody do that one really quickly on their paper. Tyra and Logan, are y'all done? I just saw y'all talking. That's why I wanted to make sure. All right, Griffin, walk me through this one. Okay. Hang on one second. My pen's not. There he goes. No, it's supposed to be a 1. My pen was jumping everywhere. Okay. Okay. Can I reduce? I'm done. 3 will go into 18, but 3 won't go into 19 evenly. Anybody have a question on that one? All right, now. Seven minus 4 and 1/2. Okay. Well, you can't go 7 minus 4 and then 0 minus 1/2. Okay. I can do my whole number. 7 minus 4 we know is 3. That's legit, right? But this one has no fractions. So can I take part of nothing away? No. So I have to force this whole number to look like a fraction. Now, I'm going to borrow from the 7. I'm going to borrow 1 whole, so that will make it come down to a what? 6. Now, how can I rewrite 1 whole as a fraction using this bottom denominator over here? You're thinking something. What are you thinking? Do I know? 6 and not 1/2. I'm going to make 1 whole. What number looks like a whole?
2 over 2.
2 over 2. Now, would everybody agree that 2 over 2 is 1 whole?
Yes.
So 1 whole and 6 whole is a total of 7, correct? So I just made it 7. It's the same number. I just made him look different. So that's 6 and 2 over 2. You always want to use the number that is over here, that bottom number. That way you don't have to multiply anything. Now I could have made it 6 and 1 over 1. That's still 7, but I don't have a common denominator now, right? So I would have to multiply this by 2 to force it to be a 2, correct? So why do I want to add more work in there when I can go straight to 2 over 2? Okay? So now, can I go 6 and 2 over 2 minus 4 and 1/2? Look at your fraction first.
Yes.
2 minus 1 is,
1.
and the bottom number is going to stay 2, correct? Because I was able to do that, now I can go do my whole numbers. What's 6 take away 4? So my answer is 2.5.
That's easy.
Okay?
What about if
All right.
I have
You guys do this one on your paper. Yes, you do have some of these for homework. Huh? Were you because that's going to be on your homework, or because we have homework? Or a little bit of both?
a little bit of both.
All right, work on this one real quick. First thing you got to do is rewrite that whole number as a fraction somehow. still recording. All right, Kendall, how did you rewrite this 10? 9 and what? I can use 10 tenths, but let's use something with this bottom number over here. So then I want to use 5 over 5. Now, what you used was not wrong, but then I've got to multiply to make sure I have the common denominator. Okay, so I've added an extra step. So we're just going to go straight to that 5 over 5. Okay? Now, Kendall, can you say 5 take away 4? Yes, and that gives me what? Okay, so 1/5. And what is 9 take away 3? That's the correct answer. 6 and 1/5. Okay. Any questions? Brenda? You actually you use a lot of these skills every day. We just don't think of it in terms like this. When you deal with money, you're constantly dealing with fractions. When you're dealing with your change and borrowing money, we just don't see it written like this. Okay? Unfortunately, though, short term, it's on your SOLs. Okay? So we have to be able to demonstrate that we're doing it. Carpenters, bricklayers, okay, plumbers, people that have to measure things, they use this a lot. Now, they don't think of it in this manner, okay? Because if I'm going to measure, let's say I'm going to come in here and measure some kind of piping, plumbing, something in here, okay? And they take a measurement, and they, it has to go up that wall, across the ceiling, and down this wall to go out into the hall somehow. There's 3 measurements, right? They measure the length of that wall, the length of the ceiling, and then the length of the wall going down. So there's 3 measurements they've had to add together, right? Now, when they're talking about units of measurement, they're using a ruler, okay? So at that point, they've dealt with fractions, okay? It might be 1 inch and like 2 parts of the inch. So 1 and 2/16 is how they look at it, which they would reduce it to 1 and 1/8. You talk to anybody who uses a ruler, they automatically know what 2/16 is without having to count and reduce. Okay? So they're using that constantly. Then they might have enough PVC pipe out in their truck, but they may have too much of it. So now they've got to cut some off. How much do I cut off? Well, now they're using subtraction. Okay? Now, do they sit here and work out a problem by, let me write it all down and add it? No, because a lot of times your carpenters and people like that can do it really quickly. Okay? They may not be a good math student in a classroom, but on their job, they can figure that stuff up really quickly. So it is used, we just don't think of it in that way. Okay, bakers are the same way. People in the kitchen, when they're talking about measurements, cups, quarts, pints, sometimes we have those measurements. Nine minus 3. Is that what you're asking me? Yes, that made my sense. Yep. All right, let's look at another one. Okay, we'll talk about this in a minute. Let's get to another problem or two, okay? But then I'll come back to you, okay? Let's look at 4 and 1/5 minus 2 and 3/4. Now, I have a fraction taking away another fraction. Okay? So my first thing is to do what? Multiply. So what am I going to multiply this one by? So 4 and 1/5. And it's going to be multiplied by 4 because of this bottom number here. And what is 2 and 3/4 multiplied by? 5. Now I want to go back and multiply. So 4 and 4/20 minus 2 and
15/20.
now we're going to look at a fraction. Can I say 4 take away 15? Can't take away that. Now, a minute ago, we made 4 look different. How did I make 4 look different a minute ago if I had to borrow? Okay, so what is the bottom number of the opposite fraction?
20.
Alright, so I would make this look like 3 and 20 over 20, right? Now, I didn't only have a 4, I had 4 and 4/20. So I've got to add this 4 to that 20. So this looks like I have 3 and 24/20. Let me see what I did. Okay, I just took my 4, okay, and I put him to the side, and let's make him look like a fraction using my common denominator of 20. So we wrote that as 3 and 20 over 20, correct? Would that equal 4? Yes, because 20 over 20 is 1, and I already have 3, so 3 plus 1 is 4. So those two things are equal. But I didn't only have a 4 here. I had 4 and 4 more pieces. Okay? So what I have to do is, when I bring my whole 3 over, in that 20 that I had a minute ago, I've got to add the extra piece here. So that gets me my 24 over 20. Now, can I subtract?
Yes.
What is 24? Take away 15.
18.
9. What's my bottom number? 20. And what's my whole number? Alright. What's the first thing we do? Somebody different. Who's not called on? Seth. Shh. We can do what now? Multiply it by what? 10. Okay. And then we're going to multiply this one by. Okay. And what am I going to get once I multiply Seth? Okay. Okay. Can I say 20 take away 45? Okay. No. If you have $20, can I borrow you 45?
No, because you don't got enough.
Okay, so 20 take away 45 does not work. So what did you do, Seth? Okay, you borrowed. Okay, I'm going to borrow. So this becomes, how can I make 15 look different? He looks like 14 and what? 50 over 50. All right, now I've got to add this 20 to it. So how much total do I have? 14 and 70 over 50. Subtract 4 and 45 over 50. Now can I take 70, take away 45? Yes, by what? Boys, stop now. What's 70 take away 45? No, I'm sorry. 35. No, 25. Yeah, 25. Yes. 70 take away 45. And what's 14 take away 4? 10. Now, can I reduce this? By what? I can reduce by 25. I can do 5 and then reduce again by 5. Okay, that's fine. But I would have ended up with 10 and 1/2. Yes. 70 subtract 45. shouldn't be 7.
Get the multiple after you multiply.
Yeah, because see, I have to borrow here to make that a 10. 70, okay, let's back up. Did everybody get, when they multiplied the common denominator, 15 and 20 over 50 minus 4 and 45 over 50? Alright, now, we could not subtract 20, subtract 45. So I had to borrow. So I made my 15 look like 14 and 50 over 50. Okay, because that actually equals 15. But I already had 20 more pieces. So that made me 14 with 70 over 50. Okay? Then I was able to subtract. Okay? Questions? That's probably your hardest part right there. Is the borrowing part and adding the extra pieces back. Okay?